Hello and welcome to the Chandara Academy. Today we're going to solve this 2022 exam exercise about the limits. Let's start. So we've got three limits, three different kind of things you want to know how to do to pass your exam. So first one, limit of f of x when x tends to 0 with f of x equal exponential of x plus 1 over 2 exponential of x. So here we have a function that seems to have no problem because we've got an exponential something with a domain equal to r and another exponential with a domain equal to r, and that is always superior to 0. And what would have been our problem? It would have been if what's under the division sign would have been equal to 0. But it's not. It's never equal to 0 for all x. So we have no problem. F is continuous in 0 because 2 exponential of 0 is equal to is different from 0. So f is continuous in 0. So limit of f of x when x tends to 0 is equal to f of 0 is equal to exponential of 0 plus 1 over 2 exponential of 0 is equal to 2 over 2 is equal to 1. So the first limit, so f of x when x tends to 0 is equal to 1. First one done. Second one, b, where, so let g be the function that given x gives square root of x plus 3 minus 2 over square root of x minus 1. Okay, so we want to find the limit, so let's call it b, of j of x when x tends to 1. So here we have a problem because when x is equal to 1, square root of 1 minus 1 is equal to 1. Square root of 1 minus 1 is equal to 0. And we don't want a division by 0. So we will have to work this a little bit. So let's try. We remember that a plus b times a minus b is equal to a squared minus b squared. We're going to use this identity to get rid of this square root and this square root. So let's begin. We're going to write j of x is equal square root of x plus 3 minus 2 over square root of x minus 1. Let's multiply by square root of x plus 1. So we've got a minus b times a plus b. So let's do it at the top and at the bottom. Square root of x plus 1. And we've got, so at the top, square root of x plus 3 minus 2 times square root of x plus 1. And at the bottom, we've got x minus 1. Okay, so now let's do the same thing with the top. So multiplying by square root of x plus 3 plus 2. So here we have our a minus b times a plus b. And at the bottom as well, square root of x plus 3 plus 2. Okay, and we now have, so now we've got x plus 3 minus 4, so 2 squared is equal to 4, times square root of x plus 1 divided by x minus 1 times square root of x plus 3 plus 2. So let's simplify this. So that's equal, plus 3 minus 4 is equal to minus 1. So x minus 1. We can simplify at the top and at the bottom. And we've got square root of x plus 1 over square root of x plus 3 plus 2. Plus 2. And this is continuous use in x is equal to 1. So as we say, limit of j of x when x tends to 1 is equal of j of 1 is equal to 1 plus 1 over 2 plus 2. Okay, so I just replaced the x's with 1 is equal to 1 half. So b is equal to 1 half. And we answered the question. Now let's compute the third limit, c. So c is equal to the limit when x tends to pi over 3 of square root of 3 times pi over 3 minus x over sinus of x minus pi over 3. So here we have a problem in pi over 3 because we will divide by sinus of 0 is equal to 0. So division by 0, we don't want that, okay? But we know that the limit when sinus of x over x when x tends to 0 is equal to 1. So we will try to find something like x into the sinus and x somewhere else. So we've got these two things that are very similar. So let's put 2 minus that will do a plus, so we do nothing, and then we will have, so c is equal to the limit when x tends to pi over 3 of minus square root of 3, so this minus, times x minus pi over 3 over sinus of x minus pi over 3. And we've got something that look, so these two things are the same and it look like this. So let's call capital X is equal to x minus pi over 3. So when x is equal to pi over 3, it implies that capital X is equal to 0. And now we've got c is equal to the limit when capital X tends to 0 of minus square root of 3 times x over sinus of x. And what we can do here, because this thing is not what we talk about, but as we are not dividing by 0, because x is not equal to 0, it tends to 0, but not equal, we are not dividing by 0, we can do that c is equal to the limit when x tends to 0 of minus square root of 3, as usual, times 1 over sinus of x over x. And now we know this limit, okay, it will tend to 1. And when this tends to 1, okay, we've got 1 over this whole thing, because the function 1 over x is continuous in 1, we can say by composition that this will be equal to minus square root of 3 times 1 over 1, so times 1. So C is equal to minus square root of 3. And we answer the question. So hope you enjoyed the video, and bye!